December 11, 1998, NASA launched a robotic space probe called Mars Climate Orbiter, and the objective was very simple. It orbits around the Mars and checks the climate. But few months after, on September 23, 1999, the whole space probe was lost, and this they first couldn't find out why this $125 million space probe got lost, and then they found it was because of a simple error. That is, the software calculated the everything with pound for second, whereas the scientists, they calculated everything with Newton second. Now it sounds like a problem that the students do, especially students who doesn't practice a lot before the test. But see, these errors happen to everyone, and that is why in physics error is very important. Now this kind of error that happens only due to the humans or calculation problem, that you put the wrong digit, or you wrote it or you added it wrongly somehow, put a different action. These are called the gross errors, and there are other two errors which we are mainly going to deal about. One is the systematic error. Systematic error is when all the measurements are consistently deviated from the true value. Now this what this changes is the accuracy. For example, the weighing machine. Sometimes every now and then we have to calibrate it, right? You have to put this mark on top of 0. But sometimes it's like 2 kg more or 2 kg less. Now this is a systematic error, because all the values you'll get, it will depend on the zero error, the initial wrong value or the wrong calibration. Now usually to get rid of them, we use we recalibrate the instrument, and other than this instrumental error, we also have experimental technique error. For example, somehow you always take the measurements from the lower meniscus, or you do not look at the value, take the value at eye level. So if you do it regularly, if it's consistent, it's also part of the systematic error. The other one is environmental error, when some environment change happen which you haven't expected. Now systematic error, to make it right, we mainly have to recalibrate the instrument. The other error is the random error. Random means random. It's unpredictable, and this haphazard fluctuation that happen in your measurements. Where the systematic error deals with the accuracy, this deals with the precision. That means you get a long range of values, and that is why what we do is usually we take the average. Now let's go through some examples of each error, and then we'll talk about how to deal with them. Now first one is a systematic error, and you can see one of the example is the zero error. To fix zero error, if there's a zero error, for example, the one you have your weighing machine, you have to fix it or recalibrate it, compare it with some result that you know. Next part is this will happen in your screw gauge or vernier calipers. Second, stopwatch running slow or fast. Say that means it won't give you the right time. So again, you have to recalibrate it or fix it, compare it with a known instrument. Then the third one is balance is not calibrated. Now this is sometimes when you use a balance, it may not give you the right value if it's not calibrated properly. It may have a zero error, or if you have a balance which has two sides, then one side may be heavier and still it shows zero. Number 4 is consistent parallax error. That means you're not taking this may come as a random error too, but it's a systematic error if it's your habit to take the reading not at eye level and create parallax error. Number 5 is instrumental calibration error. For example, if you use a thermometer and it is supposed to show 27 degrees Celsius, but it shows 25 degrees Celsius. So there's something wrong with the calibration. When they created the scale, they somehow didn't do it right, and that will create a automatic zero error. Now, next one is how to reduce the systematic error. Now, to reduce it, first of all, one way is to calibrate the instruments. For example, one you do with the weighing machine. If the mark is not at 0, then you change it to keep the mark at 0. If it's a thermometer, then you compare it with a known instrument and check if the temperatures are correct. So that deals with both the zero error and calibrate instruments. Actually, zero error is the first one, where you have to fix it in a weighing machine, or sometimes if you have a vernier calipers or a screw gauge, what happens is the zero error happens due to the old instrument, and you have to calculate the zero error and then subtract it. The number 3, read at eye level. Also, there are other methods or practices you have to do for different experiments, such as take the reading at lower meniscus, or for some liquid take the reading at the upper meniscus. Then number 4 is proper instrument setup. That means if the instrument is somehow not in the perfect condition, or the setup, for example, the floor has to be horizontal but it's not horizontal, then you may not get a proper value. And so you fix it, you make sure the experiment is in proper setup and the control variables are controlled. Number 5, use better or maintain instrument. That is, with age, some instruments they may not give the right value. Especially happens for screw gauge, slide calipers, or even sometimes stopwatches too, if the battery is too low and something is broken inside the watch. The next one is random error. One example is human reaction time. Now, this is something that we cannot get rid of easily. So we'll talk about how to minimize the human reaction error. Number 2 is estimating between scale deviations. Suppose the value is between 1 and 2. Now, different people will take different values because of different perspectives, and because there is nothing between 1 and 2, no mark, so it's very subjective. Number 3, environmental fluctuations. For example, suddenly there's a gust of wind, the fan is on, the room is not dark enough, or suddenly there's a temperature change in the room. Then number 4, we have electrical noise that may change the values in electricity problems, experiments. Number 5, repeated human positioning. Now, if you change your position, or if the observer is changing, so sometimes A takes the observation, then B takes, then that will change the values because of different point of view. So these errors are random, and it's hard to detect it. Unlike systematic, there is not a consistent change. So that is why we call it random. So how to reduce the random error? Main thing is you repeat the experiment. When you repeat the experiment, you find out which value is anomalous, and then you can change it, and then you can calculate average. For example, if you are doing the simple pendulum, now instead of one oscillation, if you take 30 or 40 oscillations, what it diminishes is the human reaction error. Now, number 3, increase sample size. Now, for example, you are measuring the height of a coin. Now, one coin height is so small, so what you do is you stack few coins and then measure the height. And because of this longer height, and because you're taking the average by dividing by 5, the resolution error minimizes, because one coin's width or height is so small that it's hard to measure, and the errors will create a big uncertainty. Number 4, instruments with high resolution. So if you have an instrument with high resolution, you don't have to be subjective and estimate a value. And number 5, control environment. For example, when you do some oscillation problem, make sure the fan is switched off. So these are basically all the 3 errors. Now the other error is the gross error. Now gross error, the only way you can do it, you have to do the experiment again. There is actually no other way. So to sum it up, to reduce the systematic error, you fix the instrument. That means calculate zero error or recalibrate it. And to reduce random error, you repeat experiment and take average. I hope this helps, and you can always follow me on the AskGuruEd Instagram or the AskGuruEd YouTube or the Facebook page, because I'm going to post all the notes there.